Hello and welcome. In this video we are going to look at frequency distributions, cumulative frequency distributions, relative frequency distributions, and a histogram, all for numerical data. In the previous example we looked at bar graphs for categorical data, and in this example we're going to look at numerical data. So example 2.3 says 20 students from a local community college were asked how many hours they worked per day. Their responses in hours are as follows. Construct a frequency distribution table for the data values. In the previous example, we looked at frequency distribution being the data grouped into classes along with how many times they occurred. And that is a frequency distribution. So we're going to do the same thing here. Basically, we're just going to go through and make a tally mark, and we will add the frequencies, and I will catch back up with you. All right, and now we have all of our data values. Again, there were 20 students selected, so we should make sure that we have 20. I will do that in a minute. The frequency would be the total number of times that the data value occurs. So we're just going to add up our tally marks. And it's always a good check. So 1 plus 3 is 4, and 4 is 8, and 3 is 11, and 6 is 17, and 2 is 19, and 1 is 20. So we've got all 20. Excellent. All right, from here, we can expand our frequency distribution to include a relative frequency, a cumulative frequency, and a cumulative relative frequency. And I'll define all of those in a moment. I'm just going to copy over all of the data values for the frequency from the previous table. All right, so I have added in the frequency to our new table, and I've also grabbed my calculator so I can do some calculations along with this one. So the relative frequency we talked about in the previous example, previous video, the relative frequency is just a fraction or ratio of the total. In this case, we know that there are 20, so this would be 1 out of 20, 0 out of 20, 3 out of 20, 4 out of 20, 3 out of 20, 6 out of 20, 2 out of 20, 0 out of 20, and 1 out of 20. Again, we can grab our calculator, and we can do the same divisions that we did before. 6 divided by 20. So we know that this is, 0.05. This is 0. This is 0.15. This is 0.20. This is 0.5. 0.30. 0.10. 0.05. All right, so we can also add in here a percent if we wanted to. This would be 5%. This would be 15%. This would be 20%. So again, we can deal with relative frequency or relative percent frequencies. They mean the same thing. Now, new thing we need to talk about is the cumulative frequency. So the cumulative frequency would be the frequency up to and including. And I have some specific notes that we'll get to right after this table that will better define relative and cumulative frequencies. So up to and including. So up to and including 0 would be 1 student. Up to and including 1 hour would be 1 student. How many students would be up to and including 2 hours worked per day? Well, this would be 4. This comes from the 1 plus 3, or 1 plus 0 plus 3. How many students work up to 3 hours? Well, this would be a total of 8 now, because again, we're doing 1 plus 0 plus 3 plus 4. So the previous frequencies all are going to get added together, and that will give us the cumulative frequency. So 8 plus 3 is 11, plus 3 is 7, sorry, plus 6 rather is 17, plus 2 is 19, this one will stay 19, and this one will become 20. And then the cumulative relative frequency is not very well used. There will be an example, we'll call it an ogive later on, that we'll look at, but basically we're just going to do the same thing we did. We'll take the cumulative frequency from the column to the left and find the total amount out of 20 as a ratio or fraction. So this one might take us a few seconds to fill in, but the math here is not all that difficult. Again, 4 divided by 20 would be 0.2. 8 divided by 20 would be 0.4. 11 divided by 20 would be 0.55. And we could also write these as percents if we wanted to. This would be 5%, this would be 20%, this would be 55%. Again, we're just multiplying by 100. From here, we could, or we will rather, define relative and cumulative frequency, and then we will look at how to graph both of these. So we have the definition for relative frequency, which is the fraction of the frequency for each class divided by the total. And the cumulative frequency is the total of all frequencies up to and including whatever class or group we're talking about here. The relative frequency can be written as either a decimal, or percent. And I have the table filled in here. Now, as we talked about with the previous example, we can also graph these. A common graph for numerical data is a histogram. It's very similar to a bar graph. It just has one slight difference, and that is because it is numerical data. Let's do the definition first. A histogram displays numerical data as vertical bars to represent the frequency each class of data occurs. The big difference between a bar graph and a histogram is that a histogram, the bars must touch. Since our data is numerical, they have a specific order. So therefore, 1 is followed by 2, is followed by 3, is followed by 4, and we need to follow that specific order. So we are going to graph a histogram for this the data set here, number of hours worked. We will label the graph here. Oops, I'm just going to handwrite this. Histogram for hours students work. Our frequency axis can be labeled frequency axis, and our horizontal axis will be, or our variable axis will be, the number of hours worked. As we talked about in the previous example, in the previous video, whenever we're drawing graphs, we always want to have a consistent scale, meaning that the distance between values are all the same. We want to make sure that we have labels on the axis and the graph, and we want to make sure that we start our values at 0. So we'll make sure we do all 3 of those while we draw these graphs. So the number of hours worked begins at 0, 2, 3, 4, 5, 6, 7, 8. I think I can spread these out just a little bit more. Sorry. And then what I'm going to do here is just put a little mark for all of these. And I'm hoping that the marks between all of these values will be consistent in their distances. And then on the frequency histogram, we have to go up to a maximum frequency of 6. So I'll put a 6 up here. About halfway is 3, 4, 5, 2, 1, and then 0. And I said in the previous in the previous video, that I will never make you make me one of these. We're going to spend some time reading graphs. I'll give you some information in a graph and ask you to decipher that information, but I'm never going to make you make me a graph. So don't worry about the building of this too much. It's just for our own information. So zeros. 1 student works 0 hours per day. 0 students work 1 hour per day, so we're not going to put a bar at 1. 3 students work 2 hours per day, so we'll put a bar here that goes up to 3. 4 students work 3 hours per day, and as we talked about before with the histograms, the bars must touch. Since we're talking about numerical data, there is a specific order to them. 2 is followed by 3, so the bars between 2 and 3 will be touching. 3 students work 4 hours. 6 students work 5 hours, so way up here. Connect this down here, connect that here. And I'm trying to do the best of my ability to keep these widths, the bars, the same width of them. 2 students work 6 hours. No students work 7 hours, and 1 student works 8 hours. So there we go. We have our our histogram for a number of hours students work. And we could spend some time here digging into this histogram. The histogram shows the number of hours that students work. So for instance, I could ask the question, how many students work 4 hours? Well, that would be asking us about the variable 4 being the number of hours worked. And we would try and figure out the height of the graph for that. We could also ask the question, how many hours do only 1 student work? And that question is asking us to find the frequency of 1. In that case, 1 student works 0 hours, and 1 student works 8 hours. And there'll be some homeworks and examples later on that will decipher this a little bit more clearly than what I'm doing right now, which is apparently not great. From here, we can also graph a relative frequency histogram. For the number of hours worked. And basically everything's going to be the same. The graphs are actually going to look quite similar in their overall shape. which is kind of cool, kind of interesting. The relative frequency, actually, let's change this. We already saw relative frequency. Let's do a cumulative frequency one. As you saw with the previous video, the frequency and the relative frequency looked quite similar. Let's do a cumulative frequency here. That was not the right way of spelling that. Cumulative frequency. So our same rules have to apply. We need to label the axes. We've got the cumulative frequency on the vertical axis. We have the number of hours worked, which is our variable, on the horizontal axis. And then we have a label on the graph. Our graph will start at 0. We will go from 0 to 8 hours worked. We will put a little mark here. We're going to try and stay consistent in our widths. That one can move over just a little bit. Again, I think I'm just going to spread this out just a bit. Again, trying to stay consistent, but also trying to make sure that we have enough room to see things. Our cumulative frequency would be up to and including. I'm zoomed out just a little bit so we can see the cumulative frequency column here. So starting at 0. I don't know why I'm having so many issues here. Our first bar rather, will go up to 1. Our last bar will go up to 20. This one's going to be a little bit more difficult to keep consistent because we have so many numbers here. So let me work backwards. Cut in half, cut in half, cut in half. And that'll give us a good approximation for these. This bar is way too wide. Let me make this first one a little bit wider. And then at 2, our bar has to go up to 4, so just below 5. And then for 3, it has to go up to 8, just below 10. And then for 4 hours worked, it has to go up to 11. For 5, it has to go up to 17. For 6, it has to go up to 19, so just shy of the 20. 7 is going to stay at 19 rather, and then 8 is going to go up to 20. Let me fix this one here. Should be the same height all the way across. All right, so that is a graph of the histogram for number of hours students worked, as well as a cumulative frequency histogram for the number of hours worked. Again, this are histograms. Histograms are used for numerical data. The bars must touch. And I have one more quick example I'd like to add into this video before I finish it. This last example is an example from a homework question. This asks us, based on the frequency distribution above, find the cumulative frequency for the class of 31 to 34. Your total should include the frequency for this class. So we would want to include up to and including all of the values. Again, cumulative frequency is up to and including. I believe the student that attempted this question when they sent it to me was trying to do the relative frequency, not the cumulative frequency. So we would have 6 plus 7, which would be 13, plus 4, which would be 17. 17 plus 9 would be 26. 26 plus 9 would be 35. So the cumulative frequency for the 31 to 34 class, would be everything up to and including, would be a total of 35. I apologize for the long video, but thanks for watching, and I'll see you on the next one.